But again, we're here to understand radiation, the regulations as it pertains to this instrument, and then the instrument itself. So anyway, radiation is just a form of energy in either particles or waves that are produced from atoms, whether it be from the nucleus in some cases, for the electron shells in other cases, but it's just energy. And you'll see that here is the electromagnetic radiation spectrum. And the reason why we have to go through this exercise with this instrument is that we're down on the bottom there where it says X-ray and gamma radiation. We're using gamma to produce X-rays. So that's why they make us go through this exercise. If we were up at radio frequency, we wouldn't be doing this class, but the instrument wouldn't work. And again, just another look at the spectrum as it moves out in the different energy ranges and so on. You see X-ray and then gamma is part of that. Now, radiation comes in two forms, ionizing and non-ionizing, okay? And you'll see that ionizing, they call it that because it's what it does. It ionizes atoms, where non-ionizing cannot do that. It doesn't have the energy. And you'll see that ionizing radiation begins at 10 electron volts, okay? So again, our instrument, the tube in the instrument is 40 kiloelectron volts. So well above that line in the sand, but still in the scheme of things, a very low form of radiation. So again, showing that the ionizing radiation comes in two forms. There's particles, which consist of both alpha and beta particles. You see there that alpha are neutron. They're a little heavier and bigger particles. Beta a lot smaller. And then waves, which again are the X-ray and gamma rays. And they're high energy light. And again, this is just an illustration showing where the different types of radiation are produced, either in the nucleus or sometimes the electron shell. Now, this is why they get a little more nervous about X-rays and gamma radiation because of its penetrating capability. You'll see here that if you could actually see an alpha particle, which of course you can't, but if you could and you saw one coming at you, you could hold up a piece of paper and block it and be safe, okay? But beta, a little bit more substantial, a piece of plastic, but X-ray and gamma radiation, you'll need lead to stop them from penetrating, okay? So that's why the regulators we have to go through this class because the instrument is an open beam. That's the way it's designed to use. So, you know, you have to worry about this penetrating capability. Now, these are units of measure that are used for radiation, a rad, radiation absorbed dose, and then a rem, Roentgen equivalent man, and they named it after Wilhelm Roentgen, who discovered X-rays, and I guess they decided to use his name for the unit of measure because he was a very bright guy, not just because he discovered X-rays, but when he was going to test out his new little invention, he was thinking about putting his own hand under there, and he goes, maybe not a good idea. He says, come here, dear. He used a wife, so she was the first one that had her hand shot. Okay, I don't know what happened to her. But anyway, you'll see here that when you're doing X-rays, the factor is 1, so rem and rad are virtually the same thing, okay, as far as the unit of measure. And the X-ray and gamma rays are the least damaging, they're the most penetrating, but they're also the least damaging form of radiation, okay? Where alpha, as you see there, is a factor of 20, so in that case, a rem is a lot more intense. So the alpha doesn't have the penetrating capability, but it is much more damaging. If it does get into you, it's not a good thing. All right, a little joke here. Now, radiation is everywhere. You can't avoid it, okay? And you'll see that it comes down from the sky. This is typical. There's some figures on there that are typical exposures during your living your day. Your own body produces radiation. It comes up from the ground. You can't get away from it. But the idea when using the instrument is to, not add to that background. Now this is showing the biological effects, so different parts of the body that are more and least sensitive to the radiation. So obviously things with rapidly dividing cells, softer tissue, and things like that are much more sensitive to radiation.